researchers discovered something ridiculous at the core of the massive cluster of galaxies, which includes our Milky Way, while tracking the directions and speeds of galaxy migration. Galaxies, like stars, planets, black holes, and all other objects in the cosmos, are always in motion. Before we go further and approach this enigmatic and terrifying phenomenon, we would like to invite you to subscribe to our channel, activate the notification bell, and give us a like if you enjoy the video Foreign Music. There is probably a mysterious object that is drawing in and possibly consuming galaxies like a vacuum cleaner. In this video, we examine exactly what this entity is and answer the question of whether we on Earth are also in danger right now. Moving toward the enigmatic entity, we must first take a closer look at the universe's structure in order to gradually come to appreciate this enormous phenomena and the potential threats it poses. The universe is composed of multiple layers and has fixed features. As of right now, astronomers probably only know a small portion of these structures. The cosmos is not a random arrangement of stars, star systems, and galaxies. Large-scale phenomena like filaments, voids, and clusters of galaxies greatly influence the distribution of matter. Filaments are thread-like connections made up of both visible and dark matter, and together they form a sort of cosmic ground grid that occasionally takes the shape of spirals or honeycombs. In the cosmic framework, observable matter builds up along the filaments. Vapors, on the other hand, are enormous spaces dominated by dark matter and nothingness. They create interstices between visible phenomena and enormous collections of nothingness. Researchers even believe that galaxies are suspended from the film elements in a unique way or move along their trajectories. Since the entire universe is, in theory, a realm of perpetual motion, cosmologists believe that these massive structures existed rather early after the Big Bang and now only expand and travel along specific trajectories inside it. Our local group of galaxies, which includes the Andromeda Galaxy and the Magellanic Clouds, is racing toward a very specific point at more than 360 miles per second. Our Earth travels around the Sun at about 19 miles per second, and the Sun, for its part, orbits the center of the Milky Way with its planets at about 125 miles per second. Since the constellation center contains this enigmatic point of attraction, the issue of whether our galaxy moves in the direction of the galaxy-eating superdust sucker may be answered clearly in the affirmative. What produced this attraction? Nowadays, scientists can fairly confidently state that a supermassive black hole at the core of every galaxy is what causes the dynamics of motion inside the galaxy. Black holes have an incredible gravitational pull and over the course of millions of years suck in entire star systems which increasingly move toward the center due to the motion dynamics. As far as this fate of our Earth is concerned, we can definitely give the all-clear because our solar system is located in one of the outer spiral arms of the Milky Way and is far from moving toward the voracious black hole at the center, but so far, researchers don't know what exactly the mysterious structure at the center of our galaxy cluster is all about. All they know is that we are currently moving toward it at about 360 miles per second. Differently than with the black holes in the center of other galaxies, researchers know so far nothing about the exact nature of this mysterious point of attraction. This attraction point was discovered only on the basis of the measurements of velocities and movement directions of galaxies. Galaxies find themselves together within the structures of the cosmos to groups which run along the already mentioned filaments. We are part of a galaxy cluster called local group. If one looks beyond that, there are many more smaller galaxy collections. The local group is a relatively small cluster, perhaps consisting of only 300 to 500 dwarf galaxies spread out across an area of 8 million light-years. Within this structure, we are already a part of hundreds of galaxy groups and one of an estimated 2,000 galaxies. They arrange themselves into galaxy clusters to form the local group cloud, with the Virgo cluster being the next largest grouping. Within this cluster, the distances are already quite great. In the closer cosmic context, The Virgo cluster is merely a component of a much bigger structure, even though its core is roughly 54 million light-years from the Milky Way. With over 100,000 galaxies and a 520 million light-year extension, the Liniakea supercluster is referred to as a large supergalaxy cluster. At its core is the enigmatic structure that is speeding toward the great attractor with a gravitational pull that is far stronger than any black hole that has been discovered to date. Millions of galaxies are gravitating toward this enormous, unidentified object. If the vast attractor is a black hole-like phenomenon, we must presume that it is currently consuming entire galaxies and clusters of galaxies. Researchers now know very little about this potentially horrific location in our universe. In fact, the only evidence of this cosmic omnivore's existence comes from model simulations that have revealed enormous measurements. This suggests that the vast attractor should have a diameter of 300 million light-years, and that its 147 million light-year distance from Earth is rather comforting. However, scientists currently know far too little about this location in the universe to declare Earth and the Milky Way to be safe. Of course, research into this phenomenon is underway, but the Great Attractor is difficult to locate because it is situated in a region of the universe that is essentially invisible from Earth. In front of the region are millions of stars, and the disk of dense gas and dust clouds, which contains our Milky Way's planets and stars, obscures our view. This researchers refer to the area that we cannot see as the zone of avoidance. Fortunately, astronomers have devised a method that enables them to investigate regions such as these nevertheless. Thanks to advanced X-ray and radio astronomy, the phenomena that are located outside the avoidance zone have been exposed behind the dust and gas cloud. Among other things, investigators discovered the Norma cluster is another sizable supercluster of galaxies. The Great Attractor's initial calculations suggested that the force behind the attraction must be more than 100 million billion times the mass of our Sun, which sounds incredibly terrifying. However, shortly after, the all-clear was granted once more, and a comparison study concluded that the point of attraction in the center of the Liniakea structure could actually only be around a tenth as large. Could this have been a calculation error? Perhaps when humans actually determine phenomena this size, we reach the limits of our technological capabilities. Researchers must use methods that provide a lot of leeway for interpretation and mistakes, since it becomes harder to identify objects the farthest they are from one another in space. We can't say for sure yet whether the Great Attractor actually exists and eats up galaxies. But the fact is that the region attracts galaxies and entire galaxy clusters and sets these formations in motion. This is because even the smallest deviations at the start of a calculation can occasionally result in large deviations in the final result. What will happen to our galaxy if the Milky Way continues to speed toward the massive attractor? Researchers currently believe that the attraction is nonlinear. This implies that our galaxy is unable to accelerate directly toward the vast attractor since straight-line motion is essentially non-existent in space. Our Milky Way is currently impacted by other significant cosmic occurrences. Between a region with extremely few celestial bodies and the Shapley supercluster, the local group where our Milky Way is located moves in tension, the dipole repeller. Since the dipole repellent is repulsive due to its low density and the supermassive Shapley cluster is attractive due to its insane gravity, we must also take into account the currents caused by these two cosmic phenomena if we wish to learn more about the fate of our galaxy. It is highly unlikely that we will even be at the tail end of feeling such influences calculations based on the Milky Way's gravitational force at that point. According to current assumptions, the Virgo star cluster, the Large Attractor, and the Shapley supercluster did not produce a coherent picture. Based on these calculations, our galaxy would be moving too quickly, roughly 30 miles per second, so there must be another force influencing our galaxy's motion and speed. This could be the equally enigmatic dark current, which is located nearly 2.5 billion light-years from our solar system and is traveling straight toward the Great Attractor before continuing on toward the constellations of Centaur and Hydra. The Vela supercluster, another supermassive galaxy cluster that was previously hidden in the avoidance zone, was discovered in 2016. It has a diameter of about 370 million light-years, and at least 100,000 galaxies within it, located at a distance of about 850 million light-years, are likely to play a significant role in the fate of our Milky Way. However, it will take some time for our researchers to get a definitive picture of how galaxies move in the universe and where they will go in the long run. For now, we can be certain that our home galaxy will not end up in the mouth of the attractor within the next few million years, if that attractor even exists. As a result, scientists are on edge of their seats. We will have to wait and see which technologies will enable us to take a closer look behind the avoidance zone in the future. It will undoubtedly not be long before scientists on this planet figure out how to. It's your turn to weigh in on the mystery of the great point of attraction. Do you think there is a secret, ravenous attractor at the center of our galaxy supercluster, or do you think it's all conjecture? As always, we appreciate your opinions and participation in the comments section. See you next time.